Vivek, what is the time complexity of this?
It will be n.
It will be n.
Yeah,
O of n square or O of n?
O of n.
Okay. I'll move on. Pi.
Will be I think it should be O of n only, because the in inner for loop it is breaking for each.
Stop. Don't tell the reason as of now. Okay, I'll just want to listen the first one.
Okay.
Yeah, everybody agrees with O of n. Anybody who doesn't agree can tell me now. Anybody who feels it will not be O n. Somebody was telling O of n square.
Half of n.
How much?
N by 2.
See, again, n by 2 is not a time complexity, as I already mentioned, right? There is no point of adding, if it is n by 2, it means order of O of n itself, right? Because the time complexity is about the proportionality. You don't put the constant. So if something time complexity is O of n by 2, it means it is O of n only. So O of n by 2 and O of n is not different. Both are same on.
Vishwa, hi.
Yeah.
Don't you think that since we have used two loops, then this would be O of n square?
Yeah, so this is what I wanted to, with this question, I want to do, same thing. So, see, most of the folks, they have been so used to figuring out time complexity based on the loops, so that they just see the loop and say that this is the time complexity. If they will see a single loop, they will say it is O of n. If they see two nested loop, they will say O of n square. And if they see three, they said O of n cube. And it's not your mistake. Actually, this is how you have been, doing all the time, and this is how you have been taught. But that is not the case. The time complexity is nothing to do with the loops that you have written. The time complexity has only to do how many times you are doing the operations, right? Why I see the two loops. So, for example, I'll take another example and I'll come here so that it makes more sense.
Vishwa, just one second.
Yeah, tell me. Go ahead. No problem.
Basically, my understanding was, see, in the nested loops, when you use nested loops, so the inner loop will run with respect to the outer loop, what the values are being used. In that case,
you're right. So in that case, that is why it is O of n square. So same thing I was going to repeat here. So for each value of I in the outer loop, the inner loop will run n times. Right? In this case, for each value of I in the outer loop, the inner loop will gonna run for n times. And the outer loop is again going to run for n times. So the total number of operation that will happen here is O of n square. So that is why the time complexity here will be O of n square. But here there's a little trick, right? So every time for each value of the outer loop, when it goes inside the for loop, it does a break statement. Okay. Because maybe you are not aware of this sentence, because of which it might have confused you. So break, what it does is that whenever you put a break, it takes you out of the for loop. I think it is true for any language as such. Whenever you use a break statement, it takes it out of you for loop. So for every outer iteration, for every value of I in the outer loop, the inner loop is running only once. It is not running n times here. So that is why effectively the total number of the times the loop is running is n only here, not O of n square. That is why the time complexity is linear and not n square. Does it answer your question, Paritosh? Is it clear? It is O of n here. It is O of n here because the inner loop is getting break. We are using a break syntax here, and what the break does is, as soon as it goes the first time itself, it comes out of the loop. So for every value of I in the outer for loop, inner is running only once. And that is why effectively the total number of operations that is happening in this is only n times. So that is why the time complexity is order of n. Make sense? Is it clear?
Yeah.
So the next question will be around just not put the question, or I'll put the question later. Okay. Can you tell me what is the time complexity of this? This is a very famous algorithm. Can you tell me, anybody tell me what is this algorithm?
Binary search.
This is binary search. Perfect. What is the time complexity of this?
Login.
Perfect. Log n. Normally, when you search in an array, by normally it is linear time. So that is why we prefer binary search, because it does the searching in the log of n time. But why log of n?
It's getting halved every time.
Getting half every time. So getting half every time, how does it relates to log?
Yeah, so it's like suppose 8 is the input and we have 8 the length of the array, and we have to check it. So every time we'll just take the half of the 8, then it will become 4, and so it's nothing but we are just dividing the power. So earlier the power was 2 power 3 and now it became 2 power 2 and then 2 power 1, like that it is.
Perfect. Very nice. So the same theory that we talked about here, the same thing applies here also. And again, if you have to visualize much better into the mathematical terms, suppose the initial size of the input was n, right? So next time it will become equal to n by 2. After that, it will become equals to n by 4. After that, it will become equals to n by 8. So every time the input size is getting divided by 2. And if you see, this is a series of log of n. Okay, so the series of log n is 1, n by 2, n by 4, n by 8, n by 16, like this. So that is why we say that the time complexity here will be log of n, because at any moment of time, the number of operations that we can do, the number of operations that we'll be doing will be log of n. So that is why the time complexity of the binary search is log of. Any doubt, guys, so far in the time complexity? So just one rule that you have to follow: don't go with your gut feeling while finding the time complexity. Always try to think logically. Try to figure out how many operations are happening, okay, and then try to relate how it is proportional to the input size. If you can do it, you can figure out correctly time complexity in each and every problem, right? So this is the only thing that you have to do. The takeaway from this is that never just look at the loop and say that this is the time complexity. Always try to figure out that how many times actually the number of operations are happening, how many times the number of operations are happening proportional to the input size. In many of the questions that we'll be discussing in our future, seeds, you will look at two loops, and also there will be no break as such. Right now I gave the break, which was a very direct hint. There will be no break as such, but still the number of operations will be only linear only. So you will have to have a you have to develop the practice of visualizing this, how many number of operations are actually happening proportional to the input size, and that is the only way you can figure out the correct time complexity, right? And this is very important. So going onwards, any problem that I'm giving you as an assignment, every problem you have to tell me what is the time complexity. Make sense?
Yeah.
Cool.